All right, so we can specify machines in two ways, either by drawing their state diagram or giving their formal definition. And so now let's look at one of these machines and try to reverse engineer and understand why it was even built in the first place and what language it recognizes. So let's start with this machine over here. And you might recognize it. It's a prettier version of this one. Okay? And think about what's an example of a length 1 string that's accepted by this DFA and a different length 1 string that would be rejected by this DFA, and do the same thing with length 2 strings. Okay. So now that we've seen a few examples, analyze some test cases, we extrapolate the pattern. So what's a good description of this machine? From Q1, if we want to have any hope of getting to Q4, we should follow the top path. We should read an A for a while, and then as soon as we see a B, we can only see Bs thereafter if we want to accept. So how might we want to tweak this a little bit so we actually get a correct description? Yeah?
If we concatenate an A after the first A star, then concatenate a B after the B star?
Yeah, so maybe we want to make sure that there's at least one A by concatenating an A after the first A star, after the A star, and we want to make sure that there's at least one B by concatenating a B after that B star. Yeah?
Does the opposite order also work?
Ooh, does the opposite order also work? What if we do like A star, B, B star? Will that work? No, yeah? Yes? Yeah, it actually does. The language of this regular expression equals the language of this regular expression. You can think about how you would prove that that works. Okay. And so in words, what are we doing here? How are we describing these strings? They're A's followed by B's. What should we add to that? Yeah. With at least one A and at least one B. So at least one A followed by at least one B's. Okay? All right, so in set notation, we might write it this way. Yes?
So for any language, is there always a DFA?
Excellent question. For any language, is there always a DFA that recognizes that language? And the answer is no. Most decidedly not. We will be able to prove that there's lots and lots of languages for which there's no DFA that recognizes exactly that language. And it will turn out that the patterns that the DFAs can capture are relatively simple. And so if you get to slightly more complicated patterns that determine membership in your language, the DFAs just, they don't do it. They don't cut it. Yeah, Ken? Absolutely. So can there be two machines recognizing the same language? Yes, and that goes back to your point about unreachable states. Because if we look at this machine and just add a Q5 over here, hanging out on its own, with dummy transitions going back to it, this is a different DFA from that one. It's got a different number of states. It's got a different transition function, but it will recognize exactly the same language, because for every single string, it will be accepted by that machine if and only if it's accepted by that machine. So multiple machines might recognize the same language. Okay. Yeah?
What's the relationship between a regular expression and DFA? I mean, is every language that can be described by regular expression can also be recognized by?
Yes. So the question here was, what's the relationship between regular expressions and DFAs? And if you just believe everything I say, then the motivation for DFAs was that we wanted to implement regular expressions. So the idea was we had these regular expressions that captured patterns, and now we were thinking, how is our computer going to tell us whether some string is described by a regular expression? And so the idea was, let's build this machine model that will capture the same notion. And so what we'll prove in about a week is that a language is describable by a regular expression if and only if it's recognizable by an automaton. Okay? So we'll have an algorithm to take us from a regular expression to compile it down to a DFA that recognizes the language that was described. And then we'll have an algorithm in the other direction as well.